Hi, good afternoon. These notes are on line plots, and this should be page 129 in your notebook for Unit 13. So we're going to go ahead and get started at the top, where we're going to describe some things about line plots. So a line plot uses a number line to show the number of times that each value in a data set occurs. An X, or a dot, is placed above that number line for every data value given. So the picture given to you has a number line from 3 to 9, and then for every X that represents one piece of data. So there was 1 3, 2 4s, 3 5s, 1 6, no 7s, 2 8s, and 1 9. So what I'd like to talk to you about, because this is not on your paper, so go ahead and write this, is that there's these three words we want to talk about called clusters, peaks, and gaps. So a cluster, you can kind of think about it like a hallway, or just something where everything's kind of grouped together. So right here, a bunch of numbers are together. So this is our cluster. A peak is where your highest amount of numbers is occurring. So 5 has the most numbers occurring, so that would be our peak. And then a gap is where there's no number. So there's a gap right here at 7. Another word that you can also use is dot plots for line plots. So a line plot shows how much data are spread out or grouped together, and this is called the distribution of the data. So how do we create a line plot? Step 1, you're going to draw a number line that includes at least that includes the least and greatest values, and then you number them in between. You're then going to place an X or a dot above the number line for every data value. So the table below shows the age of people at the Cary Public Library. The smallest number that we have is 13. And that's right here. The largest value that we have is 24. So this is a relatively young crowd at this library. All right, then from there, we're going to go ahead and number this number line, but make sure that they are even increments. So let's see if we can count by ones. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 20. Perfect. So we can count by ones. If there wasn't enough space, we'd have to count by 2s or 4s or 5s or whatever would be needed. But here we can actually just count by ones. So let's start at 13 and then work our way up. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Then what we're going to do is for every number that we see, we're going to put an X on there. We can do it two different ways. We can try to go in order and put them all together, or for everything that we see, we just put it on the chart and then cross it off. So 18, 15, 13, 14, and then you just keep doing this until you've got all your points. Now what I'm going to do is I'm going to speed up the process because I've already made an answer key over here for myself. So I'm going to just fill this in. But again, you just would go through the chart and fill it in. So I've got 5 15s, 4 16s, 2 17s, 1 19, and then 2 24s. Now what I like to do is I'd like for us to talk about what do we see in this data. So right here, this is the clustering. So let's circle that and call that a cluster. From here to here, this is our gap. So there's not any data between there. So maybe an idea that we can come up with is, this was at the Cary Public Library. This was during a time where there's an author for a young adult novel. And so you have a lot of young adults here. And then maybe you just had a couple of older adults who just really like the young adult novel. So that could be our prediction or assumption of what's going on. And then our peak was right here at 15. So this guy right here is our tallest, and that's our peak. Okay, so now we're going to describe the data, and we can use all of these pieces of information that we just wrote about our graph. So we can say that majority of our data falls between 13 to 19 years of age. you can say that there's a gap between, oh, did I not put one for 19? Sorry. Boop. A gap between 20 to 23. We could also potentially call maybe the 24s are outliers. So those are possible outliers. Okay. And that's basically a line plot. They're pretty easy, pretty straightforward. They're pretty nice because you can tell exactly how many of each data. It does get annoying when there's a lot more data than this. So if there's 100 pieces of information, that would be really annoying to have to graph. But when there's a smaller amount of information like so, it is pretty easy to graph. All right, so now we're going to try another one. So for 1 week, Julian kept track of how many glasses of water he drank every day. The results are the following. So what we want to do is we want to go ahead and create our number line and make sure we include our least and our greatest. So our least number looks like it's 2, and our greatest number looks like it's 7. So we need to go from 2 to 7 on our chart. 2, 3, 4, 5, 6, 7. So that's perfect. 1, 2, 3, 4, 5, 6, 7. And then we could put X's for every one that we see. So there's a 2, there's a 5, a 3, a 5, a 7, a 4, and another 5. All right, so what we can tell in this picture is that there's a nice peak going on right here. There's not really a lot of clustering. I would call this, I guess, the cluster here with a gap at 6. 7, I wouldn't really call it an outlier because it's not too far away from the rest of the data. And then that's it. All right. So on the inside, we're actually going to do a little bit more together because this this line plot is actually already created. But what we want to be able to do is we want to be able to interpret our line plot and be able to answer questions that go along with it. So let's go ahead and look at our line plot and see what it's about. So it says, Will was plotting the number of home runs his favorite team scored each game. Use Will's line plot to answer the question. So he likes the Cincinnati Reds, and here are the different amount of home runs that the team hit. So it looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9 games where there was 1 home run. There was 1 game where there was 2 home runs. 1, 2, 3, 4, 5. There were 6 games where there were 3 home runs. 1, 2, 3, 4, 5, 6, 7, 8, 9 games where there were 4 home runs. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And you'll see while I'm doing this in just a moment. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, and 3. All right, so I'm going to be using these numbers later to help answer some questions. So let's go ahead and get started with question 1. So how many games did they have less than 8 home runs? So right here, how many games did they have less than 8 home runs? So here's 8 home runs. Here are all the rest of the games where they had less than 8. So we can just add those together. So 9, 10, 16, 25, 30, 37, 45. So 45 games. Oh, wait. I think I'm interpreting this wrong. Hold on one second. Each X was 1 home run. Game number. Oh, okay. So I'm interpreting this wrong. One moment. Each X is 1 home run. So on game 1, they had 9 home runs. On game 2, they had 1 home run. Okay, so cross that out. That is not correct. So how many games did they have less than 8 home runs? Got it. Okay. So game 1, no. Game 2, yes, that's 1. Game 3, yes, that's 2. This was more than 8 home runs, so no. Game 5, yes, that's 3. This is less than 8, so that's 4. No. This is 5, 6, 7. So there were 7 games. Because each of these, I misinterpreted. This is the game number. So this is game 1, game 2, game 3, game 4. Got it. Okay. So there were 7 games where that happened. How many games did they get 8 or more home runs? Well, this is more than 8. That's 1, 2, 3. Okay. Number 3. What is the difference in the amount of home runs they scored on game 3 versus game 1? Well, game 3 was 6 home runs and game 1 was 9 home runs. So the difference would be 9 minus 6, and 9 minus 6 is 3. Which games did they score more than 6 home runs? So which games? Game 1, game 4, game 6, and game 7. All right, did they get less home runs on game 4 or game 3? So game 3 and game 4. So game 3 had 6 and game 4 had 9. So who had less? Game 3. All right, they scored the lowest amount of home runs on games 2 and 9. Did they get more home runs on game 3 or game 9? So game 3 was 6. Game 9 was 1. So game 3. Which game did they score exactly 1 home run? Both games 2 and 4, or both games 2 and 9. How many home runs did they score on game 1? Well, if we counted them, they scored 9 runs. If you added the home runs from game 1 and game 2, how many would you have? Well, there was 9 plus 1 gives me 10 runs total. Okay. All right, so that answers our questions for the Cincinnati Reds home runs. All right, in the following line plot, where do you see a cluster? So remember, a cluster is where a grouping is happening. So right here. So the cluster is between 4 and 5. And then the peak would be right here at 4. Okay. All right, so what you're going to do is on the right side, where you're comparing plots, go ahead and compare 4th graders to 5th graders and the time that it takes them to run an obstacle course on a field day. Down here at the bottom, you're going to be answering some questions 11 through 17, and then in just a moment, I will be placing the answer key. All right, here are the answers. So number 11 was the fastest student in 4th or 5th grade. 5th grade with the 6 minutes. So right here, this one student finished the obstacle course in 6 minutes, where the fastest 4th grader did it in 8 minutes. Well, actually two 4th graders, excuse me. How many students in each class finished the race in 10 minutes or less? So when I went over here and I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how I got 10 4th graders. And then for 5th graders, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is the median of each set of data? The way that I did this was I kind of, I counted how many there were. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I know there's 17. And I know that if there's 17 pieces of data, the 9th piece of data is the number that falls in the middle, because there would be 8 pieces below and 8 pieces above. So I found the 9th X. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this person was a 10-minute 4th grader. For for the median. And then I did the same thing over here. I just found the 9th piece of data. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, another 10 minutes. If you don't want to do that and you want to do a chop chop suey, you can. You just chop it, chop it, chop it, chop it. And then I just always start at the bottom when there's multiple numbers. And then you just work your way. And you would get the same answers as I did here. And if you don't like doing it that way, write all the numbers out in a list and then do your chop chop suey. All right, number 14, what is the mean? So this is where these numbers helped me. What I did was I found the subtotal for each of the line plots categories, and I put them at the top. So this was where 16, 45, 30, 11, 48, and 13. So then I was able to add all this together and get 174 a lot faster than typing every single number into my calculator. You can do it that way, or you can just simply type them all in. Here, same thing. My total was 6, total was 7. Here, the total was 36 because 9 plus 9 plus 9 plus 9 is 36, and then 10 plus 10 plus 10 plus 10 is 40. And then I got my total of 173 over 17, and both of those gave me, when I rounded to the 100 or to the 10th place, 10.2. So they have the same mean and they have the same median. So the range of the data set, the 4th graders was a range of 5, so they were a little bit closer together, where our 5th graders were a little bit further apart with a range of 8. The mode for each set of data for the 4th graders was 9, because I found my peak up here. So my peak was a 9-minute obstacle course finish. And then for my 5th graders, it was a tie between my 9-minute kids and my 10-minute kids. And then the last question said, which line plot has a greater range? Can you tell this just by looking at the graphs? I said the 5th grade because it's more spread out, the distribution is greater. So because I go all the way from 6 to 14, I can see that the range would be larger, and I don't even have to really do the math to figure that out. All right, if you have any questions, just put them at the bottom of the video. If you see any mistakes that I made, just let me know, and I will see you guys in class later.